Good morning, viewers. This is Kasturi Day. I'm starting with today's question answer discussion again of the motion in one dimension chapter. This is the physics chapter. According to ICSE syllabus class 9, I was continuing this video for this chapter for few videos in my last few videos. I've been continuing this chapter. So, a few more numericals are still left for discussion. So I will do that discussion today. And before I start, I will request you to please to subscribe my channel and stay tuned with me and ring the notification bell because as soon as a new video is uploaded, it will notify you. Okay? And if you are a new viewer to my channel, so please subscribe and you can like the video, press the like button and share and don't forget to meditate before starting. Okay? So with the meditation portion, I start with my chapter and discussion today. Okay? So for meditation, you need to concentrate on a light which will give you energy and make you feel interesting and be successful in your life. So think of that and positively start with the meditation as soon as possible. Okay? So let us start with the discussion. First question for today is a train is moving with a velocity of 90 kilometers per hour. It is brought to stop by applying the brakes, which produces a retardation of 0.5 meter per second square. Find the velocity after 10 seconds and the time taken by the train to come to rest. So it is telling in the question that the initial velocity of the train is 90 kilometer per hour. That is u is 90 kilometer per hour. That means it is 25 meter per second. Okay, 90 to 5 by 18. That means 25 meter per second. Then after applying brakes, it is retarded to 0.5 meter per second squared. This is the retardation is there. Acceleration, that is minus 0.5 meter per second squared, and the train comes to rest. So when the train comes to rest, the velocity becomes zero. So final velocity becomes zero, and the time taken is 10. Okay. So you need to find out the velocity after 10 seconds. What is the velocity after 10 seconds? And after that, after this retardation is applied, that is negative acceleration is applied of 0.5 meter per second square at the end of 10 seconds, the velocity is something else. Okay, and after that, it comes to rest. So that retardation is not given when it comes to rest. Okay, so let us find out the final velocity when just after 10 seconds. So v is equal to u plus at, where initial velocity, that is u, we know it's 25 meter per second, plus at, a we know as minus 0.5. So, and the time is 10 seconds. So, minus 0.5 into t, that is 10. And that will give us 25 minus 5, and that will be 20 meters per second. The final velocity, that is v after 10 seconds. Okay. Now, if the train comes to the second part of the question, is if the train comes to rest, that means it stops, that is the final velocity becomes zero. Okay, v becomes zero. The time taken, we need to find out when the time, what is the time when the velocity becomes zero. Okay, so again, v is equal to u plus at. We know it's 25 meter per second. Okay, acceleration is minus 0.5. But time we don't know when the final velocity becomes zero. So it will be like this. V value will be 0. 0 is equal to 25 plus minus 0.5 into t dash. Okay, t dash is the time taken when the train comes to rest. Okay, so the t dash will be 50 seconds. After 50 seconds, it will come to rest. And when brakes are applied to a bus, the retardation produced is 25 centimeters per second square, and the bus takes 20 seconds to stop. Calculate the initial velocity of the bus and the distance traveled. B portion is the distance traveled by the bus during this time. So first we need to find the initial velocity of the bus. We know the bus after retardation, and what is the retardation? Retardation is 25 centimeters per second square, and after 20 seconds, the time is 20 seconds, the initial velocity we need to find out as its final velocity becomes 0. So this will be v is equal to u plus 18 and 0 is equal to u into rho plus minus 25 into 20, that is minus 500. So u will be 500 meters per second. Okay. Now, excuse me. Second portion of the question is that we need to find out the distance by the bus during this time. So what is the distance? The formula is S is equal to ut plus square. We know it's 500 meters per second and time taken is 20 seconds. So this one will be 500 into 20 and half of this one will be half into minus 25. So that will give us 5,000 centimeter or 15 meters. Next question, a body moves from rest. It starts from rest. So its initial velocity is equal to 0 meter per second and with a uniform acceleration and travels a distance of 270 meters. So it's an S will be 270 meters. Time taken is 3 seconds. Find the velocity of the body at 10 seconds after the start. It says it travels 270 meters in 3 seconds with uniform acceleration, starts from rest, but we need to find out the velocity after 10 seconds. So let us first find the acceleration. Uniform acceleration. So let us find first the acceleration, and then we will find out the time taken. Sorry, the velocity. Okay. So S is equal to ut plus half at square. U we know as it starts from rest. So 270 we know it's 270 meters S. So S is equal to 270 is equal to 0 into 3 plus half at square, half into A into T square is 3 seconds. So 3 into 3. So that becomes 9. So it will be 270 is equal into 270 is equal to half A into 9, or you can say 270 equal to 9A, or A becomes 16 meters per second square. Now we need to find the velocity after 10 seconds. So V is equal to U plus 80. So that becomes V, we need to find out 0 plus 60, 10. That becomes 600 meters per second. So velocity, final velocity after 10 seconds. Next question. A spacecraft flying in a straight course with the velocity of 75 kilometers per second fires its rocket motors for 6.0 seconds. At the end of this time, its speed is 120 kilometers per second. Okay. After end of this time, that is after 6 seconds, it will be the speed becomes 120 kilometers per second in the same direction. We need to find out the spacecraft's average acceleration while the motor was firing. When the motor was firing, at that time, at that very point, what is the average acceleration of the spacecraft? Then the distance traveled by the spacecraft in the first 10 seconds after the rocket motor was started, and the motor start having been in the action for only 6 seconds. So given is U is 75 kilometers per second and B is 120 kilometers per second, and time is 6 seconds. So B is equal to B. So for this we can find out A, that is 77.5 kilometers per second square. This is acceleration. Now we need to find what? Second portion. We need to find what is the distance it has traveled after the first 10 seconds. So it will be S is equal to ut plus half of the square, and u we know 75 kilometer per second, the acceleration is 7.5. Okay, so u plus ut plus half a v square for S1. Okay. So two distance it is traveling first for the first 6 seconds and then the rest 4 seconds. Okay, that makes 10 seconds. So first S1 is ut plus half a v square, that is 75 into 6, that is plus half into 7.5 into 6 into 6. That will give us about 585 kilometers. For the 6 seconds, the distance traveled is 585 kilometers. Now for the next 4 seconds. Okay, so for the next 4 seconds, time is 4 seconds and the speed is 120 kilometers. So S2 will be a speed into time. Distance will be speed into time. So 120 into 4 is 480 kilometers. The total distance covered is equal to S1 plus S2. That means 585 plus 480. That is 106. Next question is, a train starts from rest and accelerates uniformly at a rate of 2 meters per second square for 10 seconds. It then maintains a constant speed for 200 seconds. Okay, so it starts with a uniform acceleration of 2 meters per second square. For 10 seconds, it can carries on with this acceleration. Okay, and then after that, it maintains a constant speed of for 200 seconds. Its speed is constant. The brakes are then applied after 200 seconds. The brakes are applied. The train is uniformly retarded, and after 50 seconds, it comes to rest. Now find the maximum velocity reached, the retardation in the last 50 seconds, the total distance traveled, and the average velocity. So given u is equal to 0 because it started from rest, and then t is 10 seconds and acceleration is 2 meters per second square. So v is equal to u plus at, that means v is equal to 20 meters per second. Okay. Then in the second portion where the retardation is applied and it will come to rest after 50 seconds. So the retardation in the last 50 seconds, what will be that? For the B section, u is equal to 20 meters per second, and V as it comes to rest, so it will be 0 meters per second, and T is equal to 50 seconds. So V is equal to V plus AT. That means A is what? Minus 0.4 meter per second square. Okay, so retardation the last 50 seconds is 0.4 meter per second square. Now for the final 10 seconds, what is the total distance traveled? Okay. So u we know it's 0 and acceleration is 2 meters per second square. So s is equal to ut plus half square. Okay. Now for the first 10 seconds. So we need to first 10 seconds, then 200 seconds, and then just a minute. It will be like this. First 10 seconds, then yes, for the next 200 seconds, and then for the next 50 seconds. Okay. The question is, what is the total distance traveled? So first 10 seconds, it will be S1, that will be equal to ut plus half into square, that is 0 into 10 plus half into 2 into 10 square. Okay, so that will be 100 meters. So first distance S1 for the 10 seconds, it will be 100 meters. Now for the next 200 seconds, so speed into time 20 into 200. Speed is 20 and 200 is the seconds time. So that will be 4,000 meters. And for the next 50 seconds, this will be 20 so 20 into 50 plus half into 0. Because its retardation is there. So minus 0.4 into 50 square. So that will give us 500 meters. So total distance will be S1 plus S2 plus S3. And that will be 100 plus 1,000 plus 5. The next portion is average velocity we need to find out, which will be equal to total distance covered by total time. Total distance is 4,600 meters, and total time taken is for how much? First 10 seconds, then 200 plus 50. So 10 plus 200 plus 50. So total distance is 4,600, and time taken total time is 260. 17.69 meter per second square will be the, sorry, meter per second would be the average velocity. Okay. Now draw a xt graph of an object in uniformly accelerated motion, which physical quantity is obtained from its slope. What is the nature of the slope? Constant or varying? If varying, is it changing uniformly or non-uniformly? Now the graph xt is as follows. So graph xt will be like this. It will be like a parabola. X is the distance. X on the y-axis. Okay. This 0 to x, that is the distance. Okay. And this is on the y-axis. And time axis is on the x-axis. Okay. Now the slope at any point gives the velocity of the motion. At any point, the slope on the any point of the graph, that will be the velocity of the motion. The slope is varying because it's parabolic. It is constant. It will go in a straight line from the passing to the origin. Then that will have the constant. As it is a parabola, it shows that the velocity is varying. So this varies. And the change is then the given figure shows the distance, time, and speed time graphs for two objects, P and Q, moving along the same direction. Infer which object is moving with a greater speed and now first move on to one is distance time graph, like the speed time graph. First we move on to the distance time. Here the slope of the distance time graph gives the speed. Hence, more slope, more will be the speed. More is the slope, more will be the speed. So more slope in what? The Q1. Slope for Q is more. So that is having a more slope and therefore the speed of Q is more. Now next we will move on to the speed time graph. That is the B portion where we see it represents an acceleration if the given graph in the given graph, the slope of the speed time graph of the object P is smaller than that of Q. So P is smaller than Q. Q has a more slope than P. Okay, so the acceleration of P is smaller. So it is directly proportional. The slope is directly proportional to the speed of the object. More slope, more speed. Less slope, less. So P is having less slope, so it has less speed, and Q is having more speed, so more slope, that is more speed. So the acceleration of the object Q is greater than that of. Next is a space ship traveling in space at 400 kilometers per second fires its engine for 10 seconds. Okay, so that its final velocity becomes 600 kilometers. Okay. So its initial velocity was 400 kilometers per second, and its final velocity becomes 600 kilometers per second. Find the total distance traveled in 6 seconds, starting from the time of fire. So first we need to find out the acceleration and then we find out the distance. Next, so B we know, time we know. So B is equal to U plus AT, so we need to find the acceleration from this formula, that is A is equal to 8 per second square. Now distance traveled for the S1 motion is given by C1 is equal to ut plus half t square, where t is 10 seconds. So we need to find out it's telling the full distance by the space within 60 seconds. So first 10 seconds we need to find first. That is for first 10 seconds it will be S1 is equal to u plus half t square, that is 400 plus half into 10, that is 5,000 kilometers. Now after the 10 seconds, the spaceship will travel with uniform acceleration of uniform speed of 60 kilometers per second. So no acceleration is there. Uniform speed, no velocity, no acceleration. So because maybe the direction is changing. So distance traveled for the next 50 seconds will be 3 into time, that is 60 into 50 seconds. 60 seconds we need to find out. So 10 seconds we have already found out. So leftover time is 50 seconds. So we need to find out the distance traveled with the speed of 600 kilometers per hour per second by in 50 seconds. So that will be equal to 30,000 kilometers. So total distance will be 5,000 plus 30,000. That will be equal to 5,000 kilometers. Next is an insect is crawling on a cycle rim of radius r. What is its distance when it comes to half of the rim and the full rim? Okay. So radius is r, and half of the cycle rim is equal to half of the circumference of the rim, and that will be height of half of the cycle rim is half of the circumference of the circle. That is semicircle. So semicircle, total circle circumference is 2 pi r. So half means half into 2 pi r, that is only pi r. Okay. And if it is full ring, full circumference, that is 2 pi r. And r here, its radius and it's denoted by capital R. So it will be 2 pi capital R. Okay. Next is, consider a body is initially moving with a velocity of 18 km per hour, which starts decelerating at a constant rate of 2 km per second square. Determine the time at which the body becomes stationary. Also find the distance traveled by the body. U is equal to 18 km per hour. That means it's 5 meters per second, and velocity is 0 meters per second, and starting decelerating, that is, it is a negative acceleration, so minus 2 meters per second. Right? So v is equal to ut plus half at u plus half at half at sorry, u plus half at I'm sorry again, v is equal to u plus 80. Okay, so that will be equal to 0 is equal to 5 plus minus within bracket minus 2 into t. So t find out t is equal to 5 by 2, that is 2.5 seconds. Next question, a car traveling at 15 meters per second takes a U-turn. Total U-turn is taken in 15 seconds without changing its speed. Speed will be the same, only its direction changes. Calculate the average acceleration of the car. So initial velocity is 15 meters per second, and without its changing speed, that means final velocity is also 15. Okay, but it takes a U-turn. Okay, and its time taken is 15 seconds. Okay, so calculate the acceleration. So acceleration will be is equal to v minus u. As v and u are the vector quantities, direction is important. So that means if the car takes U-turn, then it is 180-degree turn, then the speed stays the same. So final velocity will be equal to minus v or minus u, you can say. Okay, so acceleration will be v minus u, right? That means what? U and v are the same. So as it is changing its direction, so the v becomes, the final velocity becomes minus u. Okay, so v minus u, we know v minus u by t. So here in place of u, we can write minus v. Okay, so that means 2v by t, that means 2 v is what, 15. So 250, 2 to 15 by 15. Okay, that means 2 meters per second square. Now, a car is traveling at 108 kilometers per hour, has its speed reduced to 36 kilometers per hour after traveling a distance of 0.2 kilometers. Okay. Now, find the retardation time taken from this process. U is equal to 108 kilometers per hour and v is equal to 36 kilometers per hour. So we need to change them into meter per second, and s is 0.2 kilometers. So first we will change them into meter per second. That will be easier. Otherwise, it will be a very big figure. So u becomes 30 meters per second, and velocity becomes 10 meters per second, and s is 0.2 kilometers. So 0.2 is the constant. Now the formula is v square is equal to u square plus 2as. That means v square minus u square is equal to 2as. V square is 10 meters, 10 square minus 30 square is u square, and 2 into a we don't know, and the distance. So that means what? It will be A is equal to minus 2 meter per second. Now, therefore, we can see that P is equal to U plus AT, and we will see that T is equal to 10 seconds. So, this is the axis retardation and the time taken for this process. We need to find it. So, this is the end of the chapter of this motion in one dimension chapter. Finally, we have ended this chapter, and next we will move on to biology chapter. The third chapter we will continue. Okay. So, till then, if you have any doubt, please do write in the comment box. You can also write to your email id@gmail.com. If you want any other chapter question answers or anything, you can write in the email box, okay? And I can help you in finding out the questions and answers these chapters, okay? So please stay tuned with me. Please do subscribe my channel. And if you are liking the videos, press the like button, share the link, and don't forget to meditate before starting your day.